Hello dear students, today we are going to have a discussion on mock test series CUET in the subject of chemistry. This is brought to you by Top Scholars, the Smart Learning app. So let's begin. The very first question we are having is, which of the following has the most stable +3 oxidation state? So first of all, what do we mean by oxidation state? This is the number of electrons that an atom can either donate or receive to form chemical bonds with another atoms. So, we need to find which of the options is having the most stable +3 oxidation state. This means it needs to donate 3 electrons and still be in a stable form. So, let us see the options that are available. Option A is thulium, option B terbium, option C is europium and option D is gadolinium. So, now let's see what is the answer. The electronic configuration of GD3+ is given over here. Before that, we should know the electronic configuration of gadolinium itself. So, it will be Xe, which is the nearest inert gas. We have 4F7, 5D1 and 6S2. Herein, the electrons from over d orbital and s orbital can be donated. So, hence we are having the electronic configuration of GD3+ as Xe, 4F7, 5D0 and 6S0, since these 3 electrons are being lost. Okay. One more thing to notice is this f orbital. The capacity of f orbital is of 14 electrons. Okay. If you will half this, we will be getting 7 electrons. And this is exactly the number of electrons that we are having in this electronic configuration of GD3+. As we all know, the state is mostly stable when it is having half-filled electronic configuration, half-filled orbitals or fully filled orbitals, such as in the case of inert gas. Hence, because of this reason, the half-filled f orbital, we are having the most stable oxidation state of gadolinium. Hence, our correct answer will be gadolinium. The third question is asking us the name of the phenomenon in which the concentration on the surface of adsorbent is different from that of the bulk. We have to name the phenomenon in which this case is happening. Now, over here in the question itself, you can find a word which will give you a hint for the answer, which is adsorbent. Now, let us see the options available. So, option number A is absorption. We have option number B, which is sorption. Option C, adsorption. And last option D is occlusion. So, the phenomenon adsorption is the accumulation of molecular species at the surface rather than in the bulk of a solid, and this is termed as adsorption. So, basically you will have the accumulation on the surface and the bulk hence will differ. Okay. Going ahead, as the molecules are getting adsorbed on the surface, the concentration of this adsorbate that is being adsorbed on the surface will be different from its concentration in the bulk state. Okay. So, again with this word itself, you might have got the correct answer for this question. Here, the option C, which is adsorption, is the correct answer for this question. The next question asks us, sulfide ores are generally concentrated by which process? We need to find out what is the process through which sulfide ores are being concentrated. Let us see the options given to us. We are having the option A, which is froth flotation process. Option B is magnetic separation. Option C is gravity separation, and option D is by hand picking. Okay. Now, looking at these options, you can easily eliminate the option D, because by such a simple process of hand picking, we cannot have a concentrated sulfide ore. Okay. Now, let us see the process by which these sulfide ores are concentrated. So, here as you can see in this image, we are having the mixture feed which is being introduced in a container and then it is agitated. Okay. It is agitated to introduce the air bubbles and to mix the mixture. Okay. Now, this mixture is containing hydrophobic material as well as the hydrophilic material. Fine. The agitation of this mixture will lead to the formation of froth. Okay. We can isolate the hydrophilic material from the bottom part and we will take the froth also in another container. Hence, we have separated hydrophobic material as well as hydrophilic material. Okay. As you can see, the froth floats over the mixture. Hence, this process is known as froth flotation process. Now, let us see the explanation also. This is used for concentration of sulfide ores. We are having the sulfide ore particles are wetted by pine oil and this brings it to the froth, while the gangue particles by the water. Further, a rotating agitator, as you can see over here, it is rotating. At the center of the flotation tank will agitate, okay, will mix the mixture and draws air into it to form the bubbles. Okay. So, as a result, the foam is formed which will carry the metal sulfide particles. The foam rises to the surface of water and then floats. Okay. Going ahead, therefore, this method is known as froth flotation process because the froth is basically floating, okay, on the mixture. Hence, the correct answer for this question will be option A, froth flotation process. Now, let us go for the next question. The next question states the reactions which are happening at cathode and at anode. Okay. At cathode, we have Cu2+, which is reacting with 2 electrons to form copper. Okay, it is accepting 2 electrons. And at anode, we are having copper, which is donating 2 electrons. Hence, over here, we are having a copper ion, which is having the formula Cu2+ plus 2 electrons. Now, the reactions given above represent. What is the representation that these reactions are giving? Okay. Option A, we have electroplating of copper. Option B is electrowinning. Option C is electrolytic refining of copper. And option D is none of the above. Going ahead, we should know that electrolytic refining is a process of refining a metal. As the name itself suggests, electrolytic refining will be refining a metal which is mainly copper by the process of electrolysis. Okay, let us see the process of electrolysis also. Over here, as per the mechanism of the process, we will be having during electrolysis, a large chunk or slab of impure metal is used as the anode. So, the anode will be having a bigger diameter, okay, with a thin strip of pure metal at the cathode. That means cathode will be looking like this, okay. So, going further, what we'll be having is at anode, the oxidation process will occur and at cathode, the reduction will occur. Here is the image of electrolysis process. So this one, the thicker one as I drew, is the anode. And over here we are having the cathode. Okay, cathode is having pure copper and anode is having the impure copper. Here we are also having anode mud. Let us see what is that. So going ahead, as we already discussed, electrolytic refining of copper, the electrolyte used is acidified copper sulfate. Okay. Impure metal is made as an anode and pure metal is made as a cathode, as we have already seen in the image. On passing the electric current, as you have seen, there are batteries arranged. So we could pass the electric current through the electrolyte and the impure metal from anode will dissolve into the electrolyte solution and pure metal from copper sulfate solution is deposited on the cathode, okay, which was pure copper. Hence, at anode we are having this reaction and at cathode we are having this reaction, correct, which was already stated in the question itself. Going ahead, the soluble impurities go into the solution and the insoluble impurities settle down at the bottom of an anode, and this is only known as anode mud. Okay, we were seeing the anode mud below the anode itself. Hence, the correct answer for this question becomes option C, which is electrolytic refining of copper. Now, let us go for the next question. Question 8 asks us, which is the correct stability order for following hydrides? Okay, so you will be given number of hydrides and we need to arrange them as per their stability. Okay, so we are having the hydride of nitrogen, which is known as ammonia. Okay, we also have the hydride of phosphorus, which is known as phosphine. We have the hydride of arsenic, which is known as arsine. We have the hydride of lead, which is known as stibine. We are also having the last hydride, which is of bismuth, and its name is bismuthine. Okay. So, these are the hydrides and we need to arrange them in proper stability sequence. These are different sequences given to you in different options A, B, C, D. Let us see the answer for this question. So, first of all, hydride ion is a small ion. Okay. It will form stable compound with small lithium ions. Further, we will see the stability decreases as the size of the cation increases. Okay. So, basically we can say as the atomic size increases, the cation size will also increase. Okay. Going ahead, when we are increasing the size of the cation, the lattice energy in return of these hydrides will tend to decrease. Okay. Hydride stability reduces as one moves along the group from NH3 to BiH3. That means if we go down the group, we will having the stability reducing. Okay. Hence, this is because the bond dissociation enthalpy has decreased. The size of the central atom increases down the group. That was the statement for atomic size increasing down the group. Hence, the bond with the hydrogen becomes weaker, as a result of which the stability decreases while we are moving down the group. Hence, we can say the correct answer will be option A, because nitrogen is found on the top of the group and bismuth is placed at the bottom of the group. Hence, this will be the most stable and this will be the least stable hydride.